Center for the Ethiopian Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Welcome to today's lesson on some important compounds of selected non-metals. Today, we will be learning about sulfuric acid. In our last lesson, we learned about the industrial manufacturing of nitric acid using Ostwald's process. We learned about the 3 steps involved in this process, and we learned how to write the chemical equations that represent them. We also learned about some of the chemical properties of nitric acid and some of its uses. In today's lesson, we will explain the steps involved in the contact process, which is the method of industrially producing sulfuric acid. We will also discuss some of the chemical properties of this non-metal and some of its uses. Let us begin. Sulfuric acid is the world's most important industrial chemical. In fact, the rate at which a country consumes sulfuric acid is used as a measure of its industrialization. Let us discuss some of the chemical properties of this important non-metal. Pure sulfuric acid has a melting point of 10.5 degrees Celsius and a boiling point of 338 degrees Celsius. Concentrated sulfuric acid, as well as anhydrous sulfuric acid, mixes well with water. Anhydrous means that it does not contain any water. When this mix occurs, a large amount of heat energy is released. If water is poured into concentrated sulfuric acid, the heat that the reaction creates eventually causes the water to boil. The water will splash violently, so this is not a very safe way to dilute strong acids. Instead, a much safer way to dilute strong acids is to pour the acid carefully into the water while stirring. Concentrated sulfuric acid has strong oxidizing properties. So, we have already stated that sulfuric acid is produced using the contact process. This process makes it possible to manufacture sulfuric acid in the concentrations that are required for industries. Before we go through the steps involved in the contact process, let us do an activity. In a moment, you will see a list of statements about sulfuric acid. Please decide whether each statement is true or false. If you think a statement is false, please correct the error to make it a true statement.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Hello, everyone. I am sure that you had no problem figuring out which statements about sulfuric acid are true and which statements are false. Let us go through each one together. Statement A is true. Sulfuric acid is the world's most important industrial chemical. Statement B is false. It is not safe to dilute sulfuric acid by pouring water into it. The water will boil and splash violently. It is much safer to add the acid to the water cautiously while continually stirring the mixture. Statement C is true. Concentrated sulfuric acid has strong oxidizing properties. Statement D is false. The rate at which a country consumes sulfuric acid is a measure of its level of industrialization, not its death rate. Statement E is also false. Sulfuric acid is produced industrially using the contact process, not Ostwald's process. I'm sure you remember that Ostwald's process is used to manufacture nitric acid. The contact process involves 4 steps. First, sulfur is burned in air, which produces sulfur dioxide. In the second step, the sulfur dioxide is then converted to sulfur trioxide. This process is quite slow, but it is quickened by heating the reaction mixture to 400 degrees Celsius along with the presence of a catalyst. Vanadium pentoxide is used as the catalyst. This process is called contact process. This is because the sulfur dioxide and the oxygen molecules react when they come into contact with the surface of vanadium pentoxide. In the third step, the sulfur trioxide that is formed is then passed into concentrated sulfuric acid. This reaction produces pyrosulfuric acid, which is also known as oleum or fuming sulfuric acid. In the fourth step, water is then added to the pyrosulfuric acid to produce a pure and aqueous solution of sulfuric acid. Now we know how sulfuric acid is produced. Let us discuss some of its uses. Like ammonia and nitric acid, sulfuric acid is used to produce fertilizers. It is also used to produce detergents, plastics and paints, as well as a number of explosives. In addition to being a good oxidizing agent, sulfuric acid is also a good dehydrating agent. Thus, it is often used to dry neutral and acidic gases such as nitrogen, oxygen, and carbon dioxide. Sulfuric acid is used as an electrolyte in car batteries and as a catalyst to manufacture a number of chemicals. Students, please answer the following questions. What is the catalyst that is used to speed up the conversion of sulfur dioxide to sulfur trioxide during the contact process? What is another name for pyrosulfuric acid? What are 3 uses for sulfuric acid?
Students, let's get ready. Begin. Time's up! Let's get back to our lesson.
Hello again, students. Let us answer these 3 questions together. Vanadium pentoxide is used as a catalyst to speed up the conversion of sulfur dioxide to sulfur trioxide during the contact process. Pyrosulfuric acid is also known as oleum or fuming sulfuric acid. 3 uses for sulfuric acid could include the production of fertilizers, plastics, and explosives. You might also have mentioned that it is used in paints, car batteries, and as a catalyst to produce many chemicals. In today's lesson, we learned about sulfuric acid. We learned about some of its chemical properties. Some properties include sulfuric acid's violent reaction with water and its melting and boiling points. We went through the steps involved in the contact process and learned that the name of this process is taken from the reaction that sulfur dioxide and oxygen molecules have when they come into contact with the surface of vanadium pentoxide. We also learned that sulfuric acid has similar uses to ammonia and nitric acid. It is used to produce fertilizers, plastics, and explosives. This brings us to the end of today's lesson. Until next time, thank you, teacher. Thank you, students.